Okay, so without further ado, we start with the part one, which is the electricity generation. This is a more towards on how we generate electricity based on conventional method, okay, which is the coal, um, and then hydroelectric, and then we will also touch briefly about the emerging renewable energy such as solar and also wind turbine. But our main focus in this topic will be more on the conventional power generation, which is we relate on the coal combustion, okay, coal combustion, and then about hydroelectric. So this is actually the objective, okay. So in the end of this part one, okay, the student should able to list and describe conventional and new methods of electrical power generation. And then the second one discuss configuration of two types of conventional power generation, namely the steam, which is the coal generation, the coal combustion, and then also the hydroelectric. And the third one is the calculate the parameters and performance related to electricity generations. And for your information, if you have referred to my Ahmed, can you mute? Okay. If you refer to my video YouTube for this subtopic, there is no what I call the notes. Okay, video notes on this slide. I am more towards on the what I call sharing the YouTube video from the for example the coal combustion, the hydroelectric, more towards on the animation. Okay, but actually that one is more towards animation. Just want to know the components and how it is work and so on. Okay, but I will post. This is recorded, so I will post this slide. Maybe several of you have difficulty on the connection stability. So after this I will actually upload this video. Okay. So the generation of electrical energy is the first process in delivering power to consumers. Okay, electrical energy can be categorized as a commodity that undergoes production process, similar to that clothes, food, and etc. Okay, so it undergoes the production process. So electricity generation is also involve a process of converting various nano-electrical energy, such as mechanical, uh, chemical, and etc., into electrical energy. The main difference in electrical energy production compared to other commodities is that the electricity must be produced based on immediate demand. The energy must be processed and transmitted at the instant it is required by the consumer. Since the electricity supply and demand process is almost instantaneous, then the electricity generation requires a very complicated technique and economic approach. Okay, so as mentioned in this previous slide, okay, the electricity must be produced based on immediate demand, and we know that the demand sometimes is actually not very not constant. It depends on the characteristic or the load profile. So the electricity generated must actually generated based on the demand. So sometimes the demand sometimes go up and sometimes goes down. So meaning that the generation of the electricity involve a very complicated technique and economic approach. Economic approach because we want to minimize losses. We want to minimize the cost. Okay, when generating the electrical power, we don't want to waste the coal. We don't want to waste the heat. Okay. So electrical energy is generated by converting non-electrical energy in suitable manner into electrical energy. And this is the most important part in this slide, okay, which is the conversion from another energy into electrical energy can be divided into two categories. Okay, so this one is very important. Okay, they can be divided into two categories. Okay, the first one is the generation of mechanical energy to rotate electrical generator. Okay, so we use mechanical energy such as come from the heat of the coal combustion, from the hydroelectric where the water flow from the dam. So if we rotate the generator, okay, and this rotation will generate electricity. So this is the first categories, generation from the mechanical. Okay, the second categories is actually we convert directly non-electrical energy into electrical energy. Okay, but this requires aid of energy storage, such as batteries. So we actually use chemical reaction from the battery to produce electricity. We can also use solar panel, which is which actually produce electricity based on the sun irradiance from the light irradiance. So it also will have some what I call uh, chemical reaction, okay, inside the PV panel to produce electricity. So there are two categories. The first one from the mechanical itself, and the second one from direct conversion from non-electrical energy, such as batteries and so on. Okay, this is the first generation. So the techniques commonly utilized for generation of mechanical energy to rotate electrical generator is this one, generation of heat. So how we actually convert mechanical energy into electrical. So the first category, okay. So some techniques is actually by generation of heat or steam. So this method is basically involve either burning of suitable fuel resources or activating nuclear reaction to produce heat. Okay, so the heat is subsequently used to turn water into dried high pressure steam, which become the mechanical energy source to move the turbine and generator shaft. Okay, and this is the list of commonly used source of energy in the methods, which is we can use coal, petroleum, natural gas, and uranium and deuterium for the nuclear fusion. Okay, to produce heat, and from the heat we actually produce the high pressure air, and then this will actually rotate the generator. And this is the second category. Oh, sorry. This is still the first category, generation from the mechanical. Okay. Um, which is we generate the mechanical energy directly from the source. Okay. This is actually generation from the heat. And the second one is generation of mechanical energy from the source. Okay. So the stored kinetic energy. So this is more towards on the kinetic energy that available is used to develop mechanical energy source for electrical generator. So the source available for this type of conversion is actually we can get from the water, okay, geothermal, wind, and also wave. Okay, so wave, this one maybe is related to the ocean. Okay, we can also list down here, which is tidal, which is also ocean. So there is a difference between wave and also tidal. Okay, if you have this surface of the seawater surface, okay, we capture the wave is actually this one is actually for wave, and the under the water here is actually tidal. Okay, so from the ocean we can actually capture the energy from the wave from the surface of the water, and tidal from under the seawater. Tidal ni this is pasang surut. Okay, and then this is the direct conversion of non-mechanical energy into electrical energy, and this among the sources are the solar energy and also the fuel cell, okay, and also battery. But the fuel cell is not very popular, even though we know that fuel cell is this solar energy and fuel cell is actually a very what I call environment friendly energy sources. Okay, this solar energy, we know that you already know what is solar energy. Fuel cell is actually related to the water. Okay, so which is actually from H2O, we extract H2O to produce to have this hydrogen only. Okay, I think maybe several years ago there is a popular marketing strategy where at that time the oil price is very very high. So so there's a marketing strategy where in Malaysia they selling a truck that use water. Okay, that use water as their fuel. Okay, actually that one is not totally water. It's actually a fuel cell based vehicle where the water is the an energy sources. Okay, but inside that engine they will extract this water to produce to extract the hydrogen, and this hydrogen is used as the fuel for the vehicle. Okay, but this fuel cell energy system is very unstable. Okay, very unstable. It requires a very what you call a good system. Okay, so we're very sensitive to the temperature. So we need to have that temperature to be maintained at this several temperature. So electrical generation station have machine that function to convert raw materials such as coal, gas, water, and etc. to mechanical energy. Okay, so the energy is used to power the synchronous generator, which is the main component in production of electrical energy. So this is the synchron generator, okay, where this mechanical energy will actually rotate the generator shaft, and from this rotation, it will actually convert into electrical. It's just like a dynamometer, okay, dynamometer in that install at your bicycle, so to produce electricity. So it is actually the same concept used. Okay. Okay, so we go for the first conventional power generation, which is what we call the thermal power station. Okay, so basically, most of our electrical supply come from this thermal power station. So the thermal power station involves conversion of heat energy from coal combustion into electrical energy. Okay, the station is based on the Rankine cycle concept, where the mechanical power is generated by evaporating water to high pressure steam in order to run the generator. The steam produced at high pressure has sufficient mechanical energy to be able to move turbine and rotates the synchron generator to generate electrical power. So this is the picture of the thermal power stations. Okay. So what is actually inside this thermal power station? So this is the main component in the generation process at the thermal power stations. Okay, so this is the coal and ash handling scheme here. Okay, coal and ash handling scheme we have, and then steam generating plant, steam turbine, synchron generator, water processing plant, electrical connecting apparatus. So from here, as you can see, this is the figure inside the typical thermal power station. We have the coal, and this coal will feed into a what I call a boiler here. So it will be heat up, and this heat will actually produce a high pressure um, air. Okay, and then this will be fed into the turbine here. So the energy inside this high pressure air will actually rotate this turbine. Okay, and it will actually generate electricity from the mechanical rotation here. Okay, and then this high pressure air will actually what we call change back into water by using condenser here. Okay, and then feed back into the boiler. Okay, so as you can see, this is the emission where the maybe the smoke of the coal burning here, okay, will actually exit from this stack. Okay, so this is actually the basic of the uh, thermal power station. So the efficiency of thermal power station is quite low. Okay, which is what you mean by efficiency of thermal power, meaning that the energy inside the coal, okay, to produce electrical energy is only 30%. Okay, 30% from the energy. For example, the energy inside the coal, okay, from the heating of the coal, maybe 1,000 calories. Okay, but only 30% of that 1,000 is actually used to produce the electrical energy. Okay, why the efficiency is very low? This is because the heat losses in various generating process, starting from the burning of the coal to the mechanical power to develop the rotation. Okay, and this is actually one of the important note here, which is I wrote last night. Okay, for the energy calculation. So actually, we know that for the energy in general, it is calculated in joule. Okay, and in electrical energy, this energy is calculated in kilowatt hour. Okay, in kilowatt hour. For the heat combustion, the coal heat combustion, okay, so it is calculated in calorie or in unit kcal, calorie. Okay, and I think this one is a very important. You need to know joule, kilowatt hour, and also calorie. And in 1 kilowatt hour, it will actually equals to 860 calorie. And 1 kilowatt hour is equal to how many joule? Can you calculate for me how many joule for 1 kilowatt hour? Do not Google, okay? What is actually power? 1 watt. Power is actually is the energy used in second. Okay, meaning that 1 watt is equal to 1 joule per second. So 1 kilowatt hour, how many joules? Okay, 1 kilowatt hour. So kilowatt hour is energy, okay? It's not power. It's actually energy. Yes, correct. Thank you, Tan Ali. Okay. So 1 kilowatt hour is equals to 3.6 mega. So, okay. Okay, next is the efficiency of the thermal power station. Okay. So we have the thermal efficiency, which is the output, the heat equivalent of mechanical energy transmitted to turbine shaft over the heat of the combustion coal. Okay, this is related to the what I call the heating. Okay, what is the efficiency from the input, from the energy from the input, which is the energy from the coal itself, over to the output, the energy that transferred to the mechanical energy to turn the turbine shaft. Okay, so actually we can see here the overall efficiency. Okay, so inside the thermal power station, there are two systems, which is the heating system and also electrical system. So the overall efficiency is the multiplication of these two subsystems, which is the efficiency come from the heating, which is the efficiency of the thermal system, and the efficiency from the electrical. Okay, from the electrical. So what is efficiency of the electrical? Is actually the electrical output over the heat of from the combustion, from the mechanical energy. Okay, and while the efficiency of the thermal is the heat of the mechanical energy transmitted over the heat from the coal combustion. Okay, so this one can be, since this is actually same, so this one can be cancelled out. So the overall efficiency is the electrical output over the heat from the coal combustion. Okay, I hope you can understand this one. Okay, so we have electrical system, efficiency of the electrical system, and efficiency of the thermal system. Usually the efficiency of the electrical system is quite high, maybe around 90%, while the thermal is around 30%. Okay. Okay, so example. So before we go to this example, okay, so I just want you to know that why kilowatt hour is a joule, is an energy. Okay, so from here actually, so 1 watt is equal to 1 joule per second, and if you actually replace this as going here, so 1 joule is equal to 1 watt multiplied with second. Okay, so that's why 1 kilowatt hour is actually kilowatt hour is actually energy. It's not power. Okay, kilowatt hour is actually energy, which is equals to 3.6 megajoule, or I can also say that this is 3,600 kilojoule. Okay, so example. Overall efficiency of a thermal power station is around 20%. Okay, the overall efficiency, meaning that 20%, so 0.2, which is come from the electrical, multiply with the efficiency of the thermal. Okay, so the overall is 0.2. 0.6 kilogram of coal is required to produce 1 kilowatt hour of electrical energy. It is known that 1 kilowatt hour of electrical energy is equivalent to 860 calories. Calculate the value of energy from the fuel source for the station. Okay, so the overall, which is 0.2, is actually electrical output over coal source. Okay, and we know that this coal source is actually based on the heating. What is the energy actually inside this coal? Okay, and I have already mentioned to you that we have three types of energy in calculation. Okay, for the heating, it is in calorie, while electrical is actually in kilowatt hour. Okay, so we cannot use two different units to do our calculation. We need a single unit for the calculation. So usually what we do is actually to use the units of calorie inside our calculations. Okay, so we need to convert the kilowatt hour into calorie, and it is given here. Okay, it is known that 1 kilowatt hour is equivalent to 860 calories. Okay. Okay, so from this equation overall here, and where you have been given the efficiency, okay, so from this equation, you will get the energy from the coal, the energy used from the coal, which is 4,300 calories. Okay, so to produce 1 kilowatt hour of energy, and due to the efficiency of the power station, which is very low, 0.2, okay, the energy used from the coal is around 4,300 calories. Okay, so this is the answer actually. Okay, this is the answer. 4,300 calories is used to produce 1 kilowatt hour of energy. Okay, or this is alternative. Okay, answer. For every 1 kilogram of coal, okay, which is from this 4,300 calories over 0.6 kilogram, you will receive that 1 kilogram of coal will produce 7,167. Okay, from here, I can also deduce that from 1 kilogram of coal, it can produce, okay, so 8.3 kilowatt hour of energy. Okay, this is actually a conversion because 1 kilowatt hour is around 860 calories. So I want to know 7,167 calories, how much kilowatt hour can be produced. Okay, so from this is actually 8.3 kilowatt hour of energy. Okay, another example. A 100 megawatt thermal station use a source of 6,400 calories per kilogram. The thermal and overall efficiencies are 30 and 27.6% respectively. Obtain the first, the coal consumption for every hours, and the second one, electrical efficiency, if the station supplies the rated electrical output, which is 100 megawatt. Okay. So the same thing from this equation, overall, which is electrical output over the coal input. Okay. The overall is around 27.6%. Okay. And the electrical output is in the kilowatt hour, but since we want to know how many calories, okay, from the coal, so we need to convert the electrical output into calories. Okay. So right now, 100 megawatt. How many kilowatt hours from this 100 megawatt hour? Okay, so how many kilowatt hour inside this 100? So what you need to do is 100 megawatt hour over 1 kilowatt hour. So it's actually equivalent to 100 kilowatt hour actually. Okay, 100 megawatt hour is equivalent to 100 multiplied with 10k kilowatt hour. Or this one is actually 1 over 5 kilowatt hour. Okay, this one 100 megawatt hour is actually equivalent to 1 multiplied 10 power of 5 kilowatt hour. And then multiply with 860 calories over the efficiency of the overall efficiency. So the energy from the coal is around 311.6 multiply 10 of 6 calories. Okay. And then to calculate how many kilograms of coal is used or is consumed in 1 hour, is what you need to do is these calories over this value 6,400 calories over per kilogram. So from this equation, so you will receive that the amount of coal is around 48,687 kilograms, which is very huge, okay, to produce 100 megawatt in 1 hour. And electrical efficiency is actually the electrical output over the electrical input, which is come from the shaft, from the rotation of the mechanical. Okay. So same, since the input is actually in calorie, okay, in calorie here, the electrical output also need to be multiplied with 860 calories. So the electrical efficiency is around 92%. Okay, so as mentioned before, the electrical system is has a very high efficiency. The overall efficiency is actually depends on the multiplication of this thermal and electrical. So if you multiply this one, 30 multiply with 92, okay, 0.3 multiply with 0.92, you will actually receive that the total efficiency is around 0.276. Okay, just multiply 0.3 multiply with 0.92, you will receive that the overall efficiency is 0.276. Okay, which is from here also you can see the electrical efficiency. If you don't want to use this what you call equation here, you can also use this equation to actually calculate your electrical efficiency. Okay, since we know overall efficiency and thermal efficiency, then you can 0.276 over 0.3, you will have the electrical efficiency is around 0.92 or 92%. Okay, so this is actually the alternative approach on how to calculate the second question here, electrical efficiency. Okay, so additional self-study questions. So this one, we will discuss also. Oops, sorry. This one. Share content. Which is this one. Okay, I am sharing with you the additional self-study questions with the solution, and this one also I have already shared with you in your group. Okay, so 2.1 and 2.2. Okay, I think this one is quite straightforward. Okay, 2.1. 2.2 is quite not straightforward, but you need to think about it, which is already given to you also, the solution. which I made last night. Okay. Okay, let's discuss 2.1. Okay. So I give it around maybe 1 minute or 2 minutes to actually for you to comprehend the question first. So I hope you can understand these questions. 75 megawatt thermal station use coal with calorific value of 6,400 calorie per kilogram. Thermal and electrical efficiency are around 30% and 80% respectively. Calculate the coal consumption for every hour if the station supply its rated electrical power, which is 75 megawatt. So please be noted that 1 kilowatt hour is equivalent to 860 calories. Okay, so given the electrical efficiency is 80%, which is 0.8, so the equation is output electrical energy over the output from the heat combustion. And we know that the output from the heat combustion is in the calorie units. So what you need to do is actually to convert the output of electrical energy, which is 75 megawatt. So this is power, okay? So to get the energy, okay, so you need to actually multiply with 860. So right now, why 75K? Because we want to see, for example, 75 megawatt hour. We might just multiply with hour, okay? How many kilowatt hour inside this one? So what you need to do is 75 megawatt over 1 kilowatt hour. Okay, 75 megawatt hour over 1 kilowatt hour. So you will have 75K kilowatt hour. So that's why 75K. Okay? Because 1 kilowatt hour is equivalent to 860 calories. So multiply with 860 calories. So the output of electrical energy in calorie is 64.5 mega calorie. Okay? So this is the output in the unit of calorie. Sorry. And then from equation 1 here, okay, from the equation 1, we can calculate what is the output from the heat combustion. Okay, so 64.5 megacalorie, which is your output of electrical energy, over 0.8. So the output from the heat combustion is around 80.6 megacalorie. Okay, and we know that the thermal efficiency is 0.3, which is, this is the equation, the output of the heat combustion over the input of the heat combustion from the coal itself. So from this equation 2, okay, we already know that the output of the heat combustion is around 80.6 megacalorie. Okay, so over the efficiency. So you will actually receive that, you will obtain that the amount of energy input from the coal is around 268.75 megacalories. Okay, so this is calories. So the total consumption of the coal in kilogram, how many coal is used? Okay, so you need to divide by this 600 and 400 calorie over per kilogram, which is given in these questions. you will receive around 41.99 kilogram. I think this one 14, you need to double check again. This is not 41.99 kilogram, I think. This one 268.75 mega over 6,400. Yes, this one is not this one is 41.99 kilogram. Okay. Or in tone unit is actually, because one tone is actually 1,000 1016. So you divide by that to convert, so you will receive that this value is the total consumption of the coal is around 42 ton. Okay. So for the solution 2.2, it's not straightforward. Okay, but I think you can refer my solution to get the answer. Okay, so I leave it to you to actually do this by your own. So we go back to the PowerPoint here. Okay, oh, I think that's all. The hydroelectric, we will actually discuss on our next class on Thursday. Okay, about the hydroelectric station. Okay, so I think that's all. You can refer to the additional question here to see 2.2 especially. Okay, try to do this. Okay, and I hope you can understand my explanation on this thermal power station. It's quite, I think it's quite new for you, so that's why I think maybe you need some time to grab this information, to absorb this information, because we have a lot of new things. For example, calories, efficiency, the thermal efficiency, and so on. Okay, so I will dismiss this class. Okay, and then I think you can look back this slide and try to do the exercise on this 2.2 and so on. Okay, so I think that's all. Thank you very much for your attention. So we dismiss this class, and I will actually upload this recorded version of this slide after I have received this, because for using this WeBack is quite complicated. That's why I didn't very keen to use WeBacks, because it is safe in cloud. So it's quite complicated to actually retrieve this recorded video from the cloud. But I try to share with you after after Webex have compiled this recorded video. Okay. Okay. So thank you very much for your attention, and please be noted on this Thursday class I will give you what they call the second assignment, the group assignment on this Thursday. Okay, so that's all. Thank you. Assalamualaikum and have a good day.